Today we are going to discuss about recurrence relation. What is a recurrence relation? When an algorithm contains a recursive function or a recursive call, what is a recursive function? A function called itself. So a recursive call to itself, then its running time can be described by a recurrence equation or a recurrence relation. Then what is a recurrence? Is a equation or a inequality that describes a function in terms of its values on smaller input. So recurrence relation is expressed in terms of a function. So function containing its values on smaller input. To solve a recurrence relation means to obtain a function defined on natural numbers that satisfy the recurrence relation. To obtain the running time of that algorithm, we need to solve that recurrence relation. So there are four methods for solving a recurrence relation. One is substitution method, another one is iteration method, third one is recursion tree method, and last one is master method. So this is an example of a worst case running time of T of n of the merge sort procedure is described by the recurrence. So here the worst case running time is the recurrence is represented as a function. Here T of n is a function. If the input is n is represented as the input size. So if input is equal to 1, that means there is only a single element in the unsorted array. So if there is a single element, the time required to complete that execution of or sorting procedure, merge sort procedure, is theta of n. If n is equal to greater than 1, that means number of elements in that array is greater than 1, that is more than one element is present in that array, then what is the merge sort procedure? If there is an array containing 5 elements, we are divided that array into 2 half. So if there are 5 or suppose if there are 10 elements, then first we divide the array into 2 halves, then it is each half containing 5 elements. So suppose n is the total element. After execution of first iteration, that size of the array is divided into n by 2. So again we are taking each half and it divided into again n by 2. So merge sort is a divide and conquer algorithm. So we divide the each step we divide the array into half. Then after it reaches to a smaller input number, then we combine that, recursively solve each subproblem, and then we combine the subproblem, that is a merge sort. So here this 2t n by 2 indicate that the this statement indicates that the problem is divided into two sub half, and each sub half have a size of n by 2. സോ നമ്മുടെ ഒരു പ്രോബ്ലം ഉണ്ടെങ്കിൽ ആ പ്രോബ്ലത്തിനെ രണ്ടായിട്ട് ഡിവൈഡ് ചെയ്യുന്നു. ദെൻ ഓരോ ഡിവൈഡ് ചെയ്യുന്നതിൻ്റെ സൈസ് എന്ന് പറയുന്നത്, ഇപ്പം ഫുള്ളിൻ്റെ സൈസ് n ആണെങ്കിൽ ഡിവൈഡ് ചെയ്തതിൻ്റെ സൈസ് എന്ന് പറയുന്നത് n by 2 ആണ്. ദെൻ ഇത് എക്സിക്യൂട്ട് ചെയ്യാൻ എടുക്കുന്ന സമയമാണ് എന്ത്, t of n by 2. Then ഇവിടെ t of n എന്ന് പറഞ്ഞാൽ the time required to complete the execution of an input or running time of an algorithm whose input size is n. n എന്ന് പറയുന്ന ഒരു ഇൻപുട്ട് സൈസ് ഉള്ള ഒരു പ്രോബ്ലം സോൾവ് ചെയ്യാനുള്ള ടൈം, റണ്ണിങ് ടൈം ആണ് ടി ഓഫ് n എന്ന് പറയുന്നത്. അപ്പോൾ ടി ഓഫ് n by 2 എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താണ് മീനിങ്? n by 2 സൈസ് ഉള്ള ഒരു അൽഗോരിതം റൺ ചെയ്ത് കംപ്ലീറ്റ് ആവാൻ എടുക്കുന്ന ടൈം ടി ഓഫ് n by 2. സോ നമ്മുടെ പ്രോബ്ലം രണ്ടായിട്ട് ഡിവൈഡ് ചെയ്തിട്ടുണ്ട്. അതാണ് 2 എന്ന് പറഞ്ഞ് ഇൻഡിക്കേറ്റ് ചെയ്യുന്നത്. ടി ഓഫ് എൻ ബൈ ടു എന്ന് പറഞ്ഞാൽ ഓരോ പ്രോബ്ലത്തിൻ്റെ സൈസ് n/2 ആണ്. ടി ഓഫ് n/2 എന്ന് പറഞ്ഞാൽ അത് എക്സിക്യൂട്ട് ചെയ്ത് കംപ്ലീറ്റ് ചെയ്യാനുള്ള ടൈമാണ് ടി ഓഫ് n/2 പ്ലസ് തീറ്റ ഓഫ് എൻ. So this is the divide and merge sort is a divide and conquer algorithm. So it take a time for or a cost for dividing cost is there and also combining cost is there. So that is a total cost is represented by theta of n. So if the size input size is greater than 1 ആണെങ്കിൽ മാത്രമേ ഇത് ഇക്വേഷൻ വരുന്നുള്ളൂ. Then solving this equation we will get the total running time of that algorithm t of n is n log n. So solving in this recurrence relation into this form, we will use four methods: substitution method, iteration method, recursion tree method and master method. Then first one is recursion methods. Here it means to expand the recurrence and express it. It is a summation of the terms of n and initial condition. So here iteration method we are expanding the recurrence equation. So given equation is expanded and it is expressed as a summation of term. So after expansion this term is expressed as a summation term and it is in terms of n and initial condition. So here one of the important parameter is initial condition. So the key is to focus on two parameter. When we perform a iteration method, we need to consider two parameter. First parameter is the number of times the recurrence need to be iterated to reach the boundary condition. So how many iteration is required to reach its boundary condition, its end condition. And second, the sum of the terms arising from each level of the iteration process. Then during this iteration process we will get the summation term. Each step we will get a summation term. So that the sum of the terms arising from each level of the iteration process is also we need to consider. Then example of a recurrence relation: t of n is equal to 1. That is if n is equal to 1. If there is a recurrence relation is given here. If the input size n is equal to 1, there is only a single element, then time required to execute that single element is 1. If n is equal to greater than 1, if more than one element is present in that algorithm, then it will take a time of 2t n minus 1. Then how will it solve? Using iteration method, that will be discussed next. Here first we write the equation t of n is equal to 2t n minus 1. So our equation is t of n equal to 2t n minus 1. So next step we need to substitute what is 2t n minus 1. If we substitute wherever n is equal to n minus 1, then we will get here this equation become, if n is equal to n minus 1, then it becomes 2t n minus 1 is equal to 2t n is represented by n minus 1. So n minus 1 minus 1, that is equal to 2t n minus 1 is minus 2. So 2t n minus 1 is 2t n minus 2. So we will substitute wherever 2t n minus 1, 2t n minus 2. So here 2t n minus 1 here. So next t of n minus 1 is 2t n minus 2. So here we will substitute 2t n minus 2. So this becomes, we can rewrite as 2 raised to 2 t n minus 2. 2 raised to 2 t n minus 2. Then here t n minus 2. What is t n minus 2? T n minus 2. Substitute here instead of n minus 2. What will be the result? Here 2 raised to 2 is 4. Then t n minus 2 is 2t n minus 3. How will we get? T of n is n minus 2 is equal to, substitute here, 2t n minus 1 minus 2 minus 1. That is 2t n minus 3. n ഉള്ളിടത്തെല്ലാം n മൈനസ് 2 കൊടുക്കുക. ഇവിടെ n എന്നുള്ളിടത്ത് n മൈനസ് 2 കൊടുക്കുക. അപ്പോൾ ഇവിടെ n ഉള്ളിടത്ത് n മൈനസ് 2 കൊടുക്കുമ്പോൾ 2t n മൈനസ് 3 എന്ന് ഒബ്റ്റെയിൻ ചെയ്യും. സോ നമ്മൾ 4 ഇൻറ്റു 2t n മൈനസ് 3 എന്ന് എഴുതി. ദെൻ 4 into 2, that is 8. 8 can be represented as 2 raised to 3. So 2 raised to t n minus 3. Then next step, that is t of n minus 3. Again, wherever n, we will substitute n minus 3. Then equation becomes 2t n minus 4. So here it is 8 2t n minus 4. That is become 2 raised to 4 t n minus 4. This is the equation. So in this equation we will have a pattern that 2 raised to 4 t n minus 4. Here 2 raised to 3 t n minus 3. 2 raised to 2 t n minus 2. Then this procedure repeated for I times to reach a boundary condition. So നമ്മുടെ boundary condition എന്ന് പറയുന്നത് t of, if we reach t of n is equal to 1 single element, that is the t of 1 is t of 1, that is the boundary condition. There is only a we divide the problem, then only a single element is fine. That is our boundary condition. To reach this boundary condition, we need to perform this procedure for ti times. So it becomes, after I iteration, it becomes 2 raised to I t n minus I. So it's after 4th iteration, it is 2 raised to 4 t n minus 4. So if after ith iteration, it becomes 2 raised to I t n minus I. So here we put n minus I is the boundary condition, that is equal to 1. So here n minus I is equal to 1. So that is our boundary condition. Then or I is equal to n minus 1. So our equation becomes, wherever value is found I, then that value is n minus 1. So we put that I value of I into here. T of n is equal to 2 raised to here I n minus I. What is n minus I? N minus I is equal to 1. So here t of n minus I is equal to 1. So our equation become 2 raised to n minus 1 t of 1. So in our recurrence relation, what is t of 1? T of if n is equal to value, that is t of 1 is equal to 1. So here t of 1 is equal to 1. T of 1 is equal to 1. Then it is 2 raised to n minus 1 into 1. So 2 raised to n minus 1 is equal to 2 raised to n minus 1. So this is our solution. Then next one is, example is, consider the recurrence relation t of 1 is n is equal to t of n minus 1 plus 1 and t of 1 is equal to theta of 1. Then this will be t of n is equal to t of n minus 1 plus 1. That is equal to t of n minus 1. What is t of n minus 1? T of n minus 1. That is t of minus 1 plus, here it is, equation become T of n into n is equal to T of n minus 1 plus 1. So T of n minus 1 is equal to T of n minus 1 minus 1 plus 1 plus 1. That is, here T of n plus n minus 1 becomes T of n minus 1 plus 1. Then this plus 1. This plus 1. That is equal to T of n minus 2 plus 1 plus 1, 2. 2. So here n minus 2. Then next step it will be T of n minus 3 plus 3. So this will be repeated. Here T of n minus 1 plus 1, that will be T of n minus 2 plus 1 plus 1. Then again it is T of n minus 3 plus 1 plus 1 plus 1. Then here it is T of n minus 3 plus 3. The next step it is T of n minus 4 plus 4, and next time T of n minus 5 plus 5. When it reaches k, or when it repeated k times, its equation become T of, instead of 5 it becomes k, that is T of n minus k plus k. So here k is equal to, our initial boundary condition is, if n is equal, T of 1 is equal to theta of 1, that is T of 1 is equal to 1. So our boundary condition is k is equal to n minus 1. So T of n minus k is equal to T of 1, that is equal to theta of 1. Then n minus k is equal to 1. So what is k? K will be n minus 1. So here T of this equation becomes, what will be the equation become? Here T of n minus k, that is n minus k is equal to 1 plus k is equal to n minus 1, that is equal to T of 1 is 1 plus n minus 1, that is 1 cancel out, that is equal to n, that is equal to theta of n. This is the solution of the recurrence equation. Thank you.